Welcome to our next Mathe Olympiade in Deutschland. We are going to solve the problem from 63rd Mathematical Olympiade, first Runde, and the last Aufgaben. So let's go. It should be 630814. Okay, so what do we have here? It's the simple one. We need to find, right? So we need to find all numbers from decimals. The number of digits will be 6, so we can write like here: x1, x2, x3, x4, x5, x6. Then what we need important is should be divided by 9. So it means the rule of dividing by 9, it means sum of I from 1 till 6 should be divided by 9 and it should be equal to 0, right? So all digits from the number should be divisible by 9. Okay, and what do we have? We also have limitation that among all these numbers we should have 2, 0, 2, 3, and in that correct Reihenfolge, in the correct order. So let's start from, as I mentioned, called brute force solution. We remember this one. We're going to start from left to right. So let's start count all numbers, all possible numbers. So we fix 2, 0, 2, 3, and we only need x1, x2 left. So the sum of this should be divided by 9. So what does it mean? It means 2 plus 0 plus 2 plus 3 plus something x1 plus x2 should be divided by 9, and this will be equal 7. So this x1, it means plus x1 plus x2, and this is x1 plus x2 should be something that could be divisible by 2. What does it mean? It should be plus 2, yes, 7 plus 2, 9, or the next step will be 2 plus 9. It should be 11. It should be next one plus 9. It should be 20. It should be 29. It should be 38. It should be 47, right? So we always plus 9. This step plus 9. We don't count everything else because it would not be divided by 9. So something in the middle. So this plus 9, and then we follow this sequence. We will have 50, so it should be 0, 2. It should be 56, and then you will see that we have the mirror. So 65, it's the same as 5, 6 mirrored, and we can go like here 74, then 83, then 92. That's all, right? So let's count number of how many we have digits. Not actually digits, but numbers. So this is, we will treat the first is as x1 and the second x2. So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay, so what do we have? The count of these numbers will be 11. Right, so what does it give us? We know the number of combination per each combination, like 2, 2, 2, 3, x1, x2, and this will be 11 possibility numbers. Okay, So now we came to most primitive stuff. We want to find different combination or different position of 2, 0, 2, 3, x1, x2. And it should be something from n factorial or something here. So, but we will go to brute force and it will be much easier. So let's count. Here we have 11. Now in this case we want to move 3 back. So x1 are also, because we count 11, we counted that x1 always be higher than x2. So this is x1, this will be x2. Actually, it's combination. So, and the order 2, 0, 2, 3 also like this. That will simplify our life. So let's move 3 to the right and x1 to the left. So we put like here. And then we can have another one to x1, x2, 3. So 3 reached the end and there is no more combination there is for this state. And each one of them has 11 variations. It should have 11 variations, except the case when we have 11, 11 here, right? So it should, yeah, it should be 11. Sorry. x1, x2. No, it's could be the case when we have 0, 2. Okay, so we can think about this later. Okay. Now let's go. Actually, it doesn't matter. Now let's move x1 more further, and we get x1, 2, and we back 3 to this case, and x2 from the end. Yeah, so we have mostly the same as here. When we fixed the 2 on this position, we fixed x1 on this position. And the question for this task actually, can we have the number something 2, 3, and then we have 2, 3, right? So actually we have here. Or the question, can we support like numbers like this one, 20, like when we have some different. So this is the question you should ask in the beginning or when you read the task. So this case, but when we have this one, we shouldn't care about what kind of numbers we have. Is it repeated or not? So we exclude this case for now. Okay, so here we remember 1, 2, 3. So we can check the same, I don't know how this will be in English, exchanges, combinations. So it should be like 2, 3, and then 2x1, x2, 2, 3. Right. Right. So here we have three combinations, 3, 3. Now we want to move x1 even further, and then it should be x1 here, and we put 0, 2, 3, and then x2, and this will be count the number of this combination, like how many 0 on second place. It should be the same number of x1 on second place, so it should be 12. 6. So x1 on second position will have 6 different combinations, and each combination will multiply 11. And when we put then x1 on first position and start from this case, so I just don't count them, it will be the same amount as we fixed 2 on first position. It should be 12, right? And because there is no other numbers on the first position, we know that it will be in total 24 different combination multiply 11, right? So for each x1, x2 variation, and it will give us so how I multiply by 11, it's I put 2 on the left, 4 on the right, and here I put 2 plus 4, right? So it should be 264. So our answer will be 264. Yeah, so again, this solution doesn't ignore duplication, or for example 2 2 0 2 3, right? No, 0 2 2 3. So we ignore all this kind of variations for now. That's all.